Hello and welcome, everyone. Happy Friday. Let's wrap up this week with an interesting session today. We're really glad to have you here for the second session of our Devon and Beyond Security series. Our topic today is identity and access management. For those who are new to Devon and Beyond webinars, these are hosted on Cloud Customer Connect, which is our Oracle community forum for end users. If you have not already, I invite you to create a free account on Cloud Customer Connect, join in discussions, ask questions, and look for upcoming events on various topics. My name is Renu Bhatt. I'm a program lead with the Customer Enablement team, and today I'm joined by Mohammed Abdul Halim, Master Principal Cloud Architect here at Oracle. We also have Chris Johnson and Gordon as esteemed panelists who will be watching out for your questions. And with that, I'll hand it over to Mohammed.
Hello, good morning, good afternoon, good evening, wherever you may be. And yes, let's dive in. So today's session, as Reno introduced, is basically focusing on identity and identity management in the cloud. And obviously, this is a critical key topic for customers who are looking to migrate their workloads onto OCI and into cloud in general. A typical use case that we see with our customers is, it'll be a company, let's call it, Vision Enterprise. It basically wants to migrate workloads to the cloud. And they have like two types of applications, let's say. An internal application, which is accessed by the company's employees through corporate IDP, and you obviously have your sort of gamut or slew of external applications. These are exposing external endpoints, and these are basically targeting your set of contractors, or let's call them, external, users. So in that case, logically, to depict this, use case, we have two sets of users. So we see those two white boxes here. We have the internal user identities, and we have the external user identities. We have another set of identities here on the right. These are your tenancy admins or developers or control plane users, we call them. These are the guys who basically need to connect into a console of some sort, and they need to basically manage their DevOps pipelines. They need to basically manage their infrastructure, run their infrastructure as code, scripts, etc. Right? So we have three different sets of users: control plane users on the right, internal users, and external users. Now, effectively now also in addition to that, Vision Enterprise has also internally multiple units. So it's an enterprise, or could be an enterprise with multiple organizations. So we want some kind of means of segregation. So they have Unit A with their own set of applications and another Unit B with their own set of applications. Now, if you look at these applications, like we mentioned, we have, internal applications and external application. Each unit has, a number of these applications, both for internal and external users. And the idea here is that contractors, for example, will be able to access your external applications. Employees will access your internal applications, and your admins, each unit will have their own set of admins. So the Unit A will have a set of admin users, and these admin users will be able to then manage, deploy, and and control and monitor the applications that Unit A is deploying. And the same applies for the admins and the employees and the contractors of Unit B. So that's obviously a typical sort of use case that we work with in terms of when we're managing identities and helping customers onboard onto the cloud. So they might actually end up leveraging their existing security setup, their external IDPs, etc. But they need to basically tailor their approach to fit into this new ecosystem into which they're introducing their workloads and applications. Excellent. So now let's basically start. Let's keep that use case in mind. Let's keep that diagram in mind, and let's basically go through the basic concepts and the main sort of security contracts that we will leverage in order to fulfill and implement that use case in the cloud, namely in OCI in this case. We will talk about identity domains. And we talked about, we've seen in this previous slide that we're basically now grouping users. We have, different sort of, sets of user populations. And the mechanism that we use for this in OCI is that concept or that notion of an identity domain. So we'll understand how identity domains work and how we can use identity domains to manage and control populations in OCI. We'll understand, the basics of users and groups and how we manage, users and groups, allocate and assign users to groups. And obviously, the authentication and MFA, how authentication works, for each type of user population, what type of, MFA capabilities we offer in the cloud, etc. So we will focus on the authentication piece. And then once you're authenticated, now you're basically, you're able to access the resources in OCI. The question now is, well, how do we then start, controlling and managing authorization? So who has access to what? This is a very critical key, aspect that we, need to basically address when we're migrating our workloads to the cloud. Now, and then we talk a little bit about tagging, how we manage resources. You'll have obviously now multiple units, multiple organizations in an enterprise that are deploying their workloads in a tenancy. How do you actually, what mechanisms and tools besides compartments that we can leverage in order to be able to, for example, monitor budgets and consumption, and be able to basically, tag resources so that we can basically monitor certain resources and control that. So this is tagging, and then we finally address, access governance, the who has access to what and when, and and managing, lifecycle events for users and controlling permissions accordingly. So if a user, for example, is deprovisioned from your enterprise IDP, how do we then manage, access controls and permissions for this deprovisioned users, and how we can actually deprovision those in the target systems? These are the key aspects that any enterprise will have to then focus on in their journey to the cloud. So let's start with this. I mean, this is now the concept of an identity domain is effectively an identity and access management stack. So, we have different types of user populations. We can actually host and manage these user populations in a separate, each population in a separate identity and access management stack. And the identity and access management stack, will then, we'll use that to manage users, to provision users, manage user life cycles, and also, manage the authentication, both inbound and outbound. So in a typical scenario like this, we have our OCI identity and access management stack, and obviously inbound authentication. So you want to basically, a user now is provisioned as a control plane user. They need to basically acquire access into the OCI IAM console. What capabilities or what mechanisms do we actually provide for this? You could see here now we can have social logon, so you can basically federate with your Google logins, Facebook, etc. So any social IDP provider can be leveraged in this case. Federated login for your enterprise IDPs. So you're an Okta shop, you're using Azure AD or Entra ID in that case. We can easily then federate into your IDP of choice. And obviously, extra capabilities layered on top of that with, multi-factor authentication, adaptive security with security policies, and, that integrate into threat provider feeds that monitor, for example, suspicious IPs, and they'll flag any attempt at authentication to your control plane or any attempt to access any resource in OCI IAM through an authentication, sourced from a suspicious IP, for example. Then automatically, your inbound authentication adaptive security will kick in and will then capture this as a threat event and will block that attempt. So these layers and capabilities we then basically leverage in order to integrate with your external IDP providers, external MFA providers, and you can see here Microsoft Active Directory, we can integrate with that as well. So this is all federation, and then your basically risk providers, this is adaptive security. We have our own integration with our own risk or threat providers, but we can basically, configure custom integrations with your risk providers of choice. So that's in terms of the inbound authentication piece. Now let's look at, once now you're authenticated, now you want to basically start integrating your applications into this authentication mechanism. Now you have basically, you can see here now a slew of different types of applications. You have, for example, SaaS applications, right? So you will have something like HCM or financials. You're provisioning this, instance of your SaaS application, and then you're actually hooking this up into your identity domains into your OCI tenancy. So an authentication, if a user attempts to connect into SaaS apps through federation, you can actually federate that authentication into OCI IAM. And then if you're in turn federating OCI IAM authentication into an external IDP provider, you have now a chained SSO type of setup, starting from SaaS, through OCI IAM all the way to your external provider of choice. So we can leverage, federated SSO for authenticating into SaaS applications. You can also, if you have a VPN client through Radius Proxy, you can basically plug in your Radius proxies into OCI IAM. Similarly, with Linux hosts, you can use privileged authentication mechanisms on Linux. And, if you have a legacy enterprise application, something like JD Edwards, and it doesn't, for example, understand, modern sort of authentication protocols like OpenID Connect, for example, what you can do is you can actually situate an app gateway in front of that enterprise application. That API gateway then effectively then modernizes your security for your application. It in turn will then connect into OCI IAM, federate with OCI IAM, and basically provide you with a modern sort of SSO authentication mechanism on top of your legacy applications. So insofar as authentication, this is the authentication journey here from left to right. Now on top here, you see now, once the authentication happens, you need to do basically manage the authorization. So we have an integral part of OCI IAM is the policy engine that actually enforces the IAM policies. And you can use, I will discuss this later in the presentation, but policies will basically manage authorization, which group has access to which resource. And also on top of that, the identity piece, authentication is not going to work unless you have that identity provisioned in OCI IAM. And the identity storage, lifecycle management, we have integrations with Active Directory. We have an Active Directory bridge, which integrates into your on-prem Active Directories, and then basically uses this integration to synchronize your user identities back and forth. We have user and access management, in OCI. We have an app catalog that you can basically use to provision integrations with third-party identity stores, and we have the provisioning bridge, which basically effectively also similarly with App Gateway, but it's now App Gateway for your user identities. If you have any legacy identity storage system, then you can basically layer a provisioning bridge on top and then use that to connect into your legacy identity store and then synchronize user identities. So these are really the three main aspects: authentication, authorization, and identity user management that we provide fully encapsulated for you within an OCI identity and access management stack, or within, as we would call it from now onwards, an identity domain. So OCI, identity access management, is referred to as an identity domain, and you can have multiple domains. So you can have multiples of these identity and access management stacks to basically manage, separate, user populations. In our use case, back to our use case, if you remember, we had three different types of users. Okay, so and this basically will map to three different types, or three different instances rather, of domains. The default domain, that default domain is created with the tenancy. The moment you provision a tenancy, it gets created with an associated default domain that cannot be deactivated or deleted. You cannot hide it from login. So it's always going to be there when you're attempting to log into your tenancy. You see that default domain as an option. That's always the default option. And, a technical detail here, it's replicated to all regions. And so, and basically the region, the default region for that default domain is the same as your home region, and it contains that tenancy administrator. So the moment the tenancy is provisioned, your seeded tenancy administrator will reside in that default domain. Then from that moment onwards, now the onus is on you to basically manage how do you want to group your user populations, right? Do you want to basically, the recommended practice is to basically spin up a separate domain for each different type of user population. So your external populations, users in the external user population will reside in the external domain. Your internal users, your employees, your unit admins, etc., your developers will reside in the internal domain. Okay. You can create as many as you need. So there's no limit on the number of custom domains that we call them. You can deactivate domains, you can remove domains, you cannot obviously deactivate nor remove default domains. And you can basically choose the regions to replicate. You can also choose the quote unquote home region for that domain. When you're basically spinning up a domain, you can specify, okay, I want that domain to exist in region A, and that region A doesn't necessarily have to be the same home region that your tenancy is using. And you can also, as we mentioned, your default tenancy administrator will always reside in the default domain, but you can have additional tenancy administrators in the other custom domains. Now, obviously, in our use case, this does not apply because, or this at least doesn't apply to the external domain, because the external domain is, strictly speaking, going to only basically host or manage external users, right? But there is the possibility that we can have an external tenancy administrator, an additional tenancy administrator residing inside the internal domain. So now let's talk about users and groups. We have three different types of users here. We have, local domain users. So we all understand a local user. Then we have instance and resource principals. So our users can be either persons or they can actually be resources. So for example, you provision a compute instance in your tenancy. That compute instance actually automatically will have an associated identity, an identity that's actually associated with that instance. Okay, so these we refer to those as instance principals. And some certain types of resources, like for example, our functions, which is equivalent to Lambda, or serverless resources. Some resources will have also their own identities. So suffice it to mention that local domain users are persons, and then instance and resource principals are effectively something like a machine identity, or for compute instances in that case, or maybe a function identity. And then those local domain users or persons can be either local or federated. So we've seen in the authentication journey that we can basically do inbound authentication, and we can federate inbound authentication with external IDPs. So these are now flagged in our OCI-IM, because OCI-IM does manage and store user identities, even though they're federated, but it will flag that user as a federated user. So you'll notice when you basically log into the console, you'll see some users will have like a checkbox flagged against the username, indicating that this is a federated domain user. So we know, okay, this now user is authenticating outside of OCI-IM. They do have an identity in an upstream external IDP, and the provisioning, there's a provisioning mechanism that actually synchronizes these user identities into OCI-IM. Good, excellent. So now, in terms of local, domain users, we have the best practice here is to try and limit the number of local users as much as possible. So 10 year 0 ideally. We have obviously a break class user. So, in case your federation breaks, you're an admin that is federating, but if the federation breaks, then, you have a break class user that you can basically use to log into the tenancy. The federated domain users that, like we mentioned here, will be the largest population in your user space. And they will represent a single named human person. And they obviously can be used for administration of OCI via the console or APIs. Okay. Instance principles, like I mentioned, these are compute instance principles, and they're rotated automatically. So all what you have to do is basically reference the identity of that instance that you're actually, or the OSID of the instance that you're connecting into, and reference that in a policy, and that's effectively now you're referencing that key that is attached to that compute instance. Groups, I think groups is self-explanatory. Groups of users, we've been using groups, we know what groups are, but it's worthwhile mentioning about dynamic groups. Now, these dynamic groups apply only to the instance or resource principles, okay? And the dynamic group is, you can say, okay, I want to basically group all instances or all compute nodes within a certain compartment. That becomes then your dynamic group. So no matter how many times you provision or deprovision instances in that compartment, they're always encompassed by this dynamic group, so that you can then reference that dynamic group in a policy without having to individually list the identities or the OSIDs of each one of those provisioned computes. So this is a very useful feature that we use quite often when we're setting up authorization for our tenancies. Now, user provisioning. So how do we push those users into OCI? Like I mentioned, in the slide, we have something like, we can integrate with Azure AD, with Okta, external IDPs, SailPoint, legacy Oracle Identity Manager, for example, for customers that are using, on-prem, security and identity management products from Oracle. These are all covered by, SCIM APIs. These are a set of standardized, provisioning APIs that these IDPs expose. And then that basically kind of simplifies the integration, challenge. Any SCIM compliant IDP, OCI-IAM knows how to talk SCIM. So as long as your target IDP or your source IDP is SCIM compliant, I'll be able to connect into it, query users, group memberships, pull users from, source A to target A. You'll be able to do all sorts of things and synchronize in both directions, as long as your target and source IDPs are SCIM compliant. You can also load users manually. So if you have a CSV file with user identities, you can basically deploy users that way. And using that tooling, for something like AD Bridge, if you want to connect into on-prem Active Directory instances, or provisioning bridge for legacy or non-SCIM compliant type of sources or targets, something like, for example, a database. You can basically layer a provisioning bridge on top of the database, and then use that provisioning bridge SCIM API to connect into OCI-IAM and vice versa, right? And similarly with LDAP. Now, in terms of provisioning, two flavors of provisioning: just-in-time and SCIM. Now, with SCIM, you're actually pre-provisioning the user before the authentication. So you ensure that when you're setting up your federation with Okta, that you ensure that you run that SCIM synchronization job, just to ensure that all users and group memberships in Okta are provisioned and synchronized in OCI-IAM, and that precedes the first authentication event, right? The authentication will fail if the user is not pre-provisioned. But if you switch on just-in-time provisioning, then what will happen then is, if an authentication event happens in OCI-IAM that precedes the provisioning of that particular user, then what will happen then is OCI-IAM will interrogate that SAML request and will be able to then, provision on the fly this user and add this user to the relevant group membership, and then basically map that local user in OCI-IAM to the federated identity coming from the external IDP. So that's the difference, the essential difference between SCIM and just-in-time provisioning, right? So that obviously Just-in-time requires a SAML IDP for this to work, so because it does interrogate the SAML request. It doesn't support user lifecycle. So, for example, say a user in your external IDP, and this is something very important for customers that they always want to basically manage, is that you'll have lots of services, native services that are, integrating into OCI identity access management or identity domains, which are in turn federated to external IDPs. And so there will be lots of users basically provisioned in multiple, across multiple, native services within OCI. So you want to basically be very careful with your user lifecycles. If a user lifecycle is if a user is deprovisioned in the source IDP, you want to make sure that that percolates all the way to OCI IM, and that all the target systems now are deprovisioned, right? So this will not happen if you're using just-in-time provisioning. It will happen if you're using SCIM, because if you're setting up that SCIM integration channel between your IDPs and OCI IM, that depending on who's authoritative in this relationship. If your external IDP is the authoritative source, then any lifecycle event in your authoritative source is going to trigger a corresponding lifecycle event in OCI IM, and that's really critical. Okay, so both modalities have their specific use cases, but SCIM is the more encompassing approach, and that's the approach that we do recommend. Now, authentication, I think we've been talking about authentication, but certain details about authentication is we use OCI API keys if you need to basically access the control plane APIs. So you'll be able to log in through the console with your username, password, and then, or if you're using Federation, you will basically end up getting redirected to your external IDP. But if you want to connect into the control plane APIs, then you can basically generate each user, has certain capabilities. If you have the API capability enabled, you'll be able to basically create an API key pair for you, and then you'll use that when you're setting up your CLI, and then just basically point your CLI to the key, your private key, and then connect. All right. Certain exceptions in terms of container registry, we use authentication tokens. So you'll basically have to log into the console, generate an authentication token, okay, an auth token, and then use that to basically connect into container registry. There are S3 compatibility modalities. You can, create customer secret keys for S3 compatibility. You can create OKE credentials. Obviously you can use your API keys to connect into your OKE clusters, but you can also use MTLS certificates for that, and you can rotate those certificates. So these are what we refer to as OKE credentials. Now, in terms of console access, we've talked about local domain users and federated users. And then we also have MFA. So you can actually, if you're, for example, using local domain users, and you can, the recommended practice is to always, enable MFA on your local users. And I'll show you this in the demo very quickly. Now, we'll start now transitioning into the authorization part of the story. And a key step when it comes to authorization is you need to basically know how you can group your users. You need to group users and grouping your resources, right? So the notion of a compartment here in this case is effectively, that's our fundamental component that we leverage in OCI to organize logically our cloud resources. And in the process, when you're organizing logically a set of components, you're also creating that sort of logical isolation, layer. So it's extremely important when it comes to separation of duties, for example, like we've seen in our use case. We have unit A and unit B. Unit A now will be its own compartment. All of unit A's, workloads, resources, compute nodes, instances, networks, etc. These will be delineated or delimited within that compartment, which creates an isolation layer around unit A's resources. So that it's for the purpose of separation that we're using it, and also it kind of facilitates not just only the isolation, but also when it comes to, for example, measuring usage and billing. So I'm the admin of unit A, and I want to monitor my own consumption, right? Because ultimately my consumption is going to basically be deducted from my cost center, right? So different units will have their different cost centers, and they will be interested in monitoring usage for their own respective compartments, right? So that this is where compartments also kind of shine here in this particular use case. And the isolation, like I mentioned, in terms of the separation and authorization. So you're only authorizing unit A, users to access, resources within this particular compartment. Now, it is logical, and this is very important. Obviously, it's a new concept for a lot of customers who are moving their workloads from on-prem data centers to the cloud. So it's important to get your head around this notion that it is a logical entity, not a physical entity, and it is also hierarchical. So you can have multiple kind of levels of depth. You can have like a child compartment embedded within a parent compartment, which is in turn embedded within a root or grandparent compartment. By default, when you provision a tenancy, there's always a root compartment. So you always get that sort of first compartment. That's your sort of root enclosing compartment. We sometimes call it the tenancy compartment. And within that, you can create as many additional compartments as needed. Okay, obviously, as long as you're restricting yourself to a hierarchy depth of 6 levels. And let's look at this. We have something called the CIS compliance landing zone. This is a landing zone that actually provisions a set of compartments and a set of policies and groups. So it basically manages all what we feel are your base security posture is actually implemented using this landing zone, and it gives you a very good starting point or baseline to basically from which to proceed to basically build and enrich your tenancy. So we provide you in this script. For example, let's look at how we configure compartments here in this landing zone. You have something like, a database compartment. All your database-related resources will exist here. Notice that that's a logical compartment. So these resources will actually need to be attached to networks. Now, the fact that they're in the database compartment doesn't mean that they cannot basically, expose or attach their VNICs to subnets, which are situated in a totally different compartment. So that's the beauty of compartments. Logically, I can basically separate and group my different types of resources. I have a database resource. I have a security compartment for all my, database for all my security related resources like logging, object storage, vaults to manage keys, etc. And then I have a network compartment, which is the green compartment that has all my VCNs, and inside my VCNs, I have my subnets. Right? So the moment, for example, I provision an ATP, if I want to expose a private endpoint, I need to specify a subnet, okay, and a VCN, right? So the fact that this ATP instance is in the database compartment doesn't mean it cannot have visibility into other resources and other compartments. And if you have the right policies, when you're actually provisioning the ATP, you'll be able to actually point the private endpoints at the respective subnet in the relevant VCN in the networking compartment. So it's once you get the hang of it, it's a very, very effective use or effective way of organizing and managing your resources. Have a look at the landing zone in the deck. There's a link to it. It's just much more than just compartments. It's policies, it's user groups. It's really a tenancy out of the box. And using that, it will really expedite your cloud migration journey immensely. Authorization. So it's an important concept that I would like to mention here is it's a closed world model. Access is always denied by default. And policies, through policies, you're basically unlocking access to resources. So by default, access to resources is always locked. And basically, the simplest form of a policy here is you're granting group access to resources. All right. So you cannot grant permissions or access to an individual user. You can only grant that to groups of users. Okay, and these these permissions will allow you access to the designated resources in your tenancy. So you can say Group A can have access to all resources in compartment A, right? But then you can also go one step beyond that and actually implement granular access controls. So you can say Unit A or Group A can have access to compartment A. Or not all resources in compartment A, but only resources with certain, Oracle OCI identities, right? So, we'll see an example of this. I mean, here, for example, this is our policy builder. And you could see here now it's pure English. So we have this kind of, syntax of, allow group name to manage. So there's a verb here, and then that's the object. The object is the type of resource. Then we have that notion of resource family. So for example, something like a secret family, that means all resources relating to secrets, right? Managing keys, managing vaults in, and then you specify the location, right? So in the simplest form, it is this: group name, verb, and then object. Group name is the subject, verb, and that's the object. Now the subject here, remember, we talked about now multiple domains. So back to our use case, if you remember, we had like 3 separate domains, right? Now each domain will have its own set of users and groups, right? So if I have a user in the default domain, I can reference that user by going, default / and then group name, right? But and if you don't specify the domain name, then it will assume by default that it's default. And then for your other custom domains, for the internal users and the external users domain, I can say, group internal / group unit A can have, manage access on all resources in compartment unit A, for example, right? So that's the structure, how it works. And that's an example. I think this is self-explanatory here: allow group administrators to manage all resources in tenancy. And that's one important point here, is that if you belong to this group, that's a sort of that's a default. It's a group that's seeded by default in your tenancy. Obviously, the seeded tenancy administrator would be the only person belonging to this group, and then you can add further local users if you like. So that group manages all resources in tenancy. And manage here, this verb manage, is the most powerful verb in an OCI tenancy. It means it can do everything with resources. It can list resources, it can read resources, it can inspect resources, it can do CRUD operations on resources. So that's how powerful this verb is. Okay, policy syntax, I think we can kind of speed this up a little bit. Now, these are the verbs: inspect, read, use, and manage. Okay, so inspect gives you the ability to list resources. Read, you're doing inspection, plus you're getting user-specified metadata and actual, metadata about the actual resource. And then use, you're doing a read plus. So you could see now here how we're layering the permissions. So these are tiers of permissions, and the use tier is basically layered on top of read. So it includes read plus the ability to work with the existing resources. Okay, and that kind of the actions and can vary by resource type, and very quickly these verbs basically map to permissions, and permissions then map to APIs on your control plane. And each API will have or require a certain set of permissions, right? And these permissions will be either encapsulated through inspect, read, or use. Now, the aggregate resource types. Now, we have individual resource types, like an instance. Or a compute instance is an individual resource type, but a compute instance or a bucket, for example, if you're using object storage, a bucket doesn't live on its own. It basically contains objects, right? And so buckets and objects can be bundled together as one object family here, as one family, and we call this the object family. So that kind of makes it easier for you if you want to basically allocate, manage permissions on buckets and objects within buckets. You can do this in one statement rather than having to basically separate this into multiple statements. Similarly, for example, with volumes, right? You can have a volume, then you attach the volume to a compute, and then you have volume backups. You can have individual permissions on these separate resource types, or you can bundle them together in a volume family. These are simple policies. I think this is self-explanatory. Let's just focus on one. For example, auditors. So if you have now, an auditor, and that auditor is going to live in that right box. Remember, in the default domain, which contains, your tenancy admins, etc. So auditors can live there in this domain as well, and you can basically give them access to inspect all resources. So that's the least, the least sort of privileged type of, verb that we can use, and allocates only inspect permissions on all resources in that tenancy. So they'll be able to, for example, list and see, okay, how many, for example, compute instances do you have in a particular compartment, that kind of level of visibility into your tenancy. Now, in terms of policies apply to child compartments, and compartments, obviously, we know that now that compartments can be hierarchical, and we can move resources between compartments. And what you can do now here is you can write a policy here in this Easy Rider compartment, and the reference, resources in Chris Johnson's compartment, and all the policies here. Or you can create a policy that you can say, for example, Easy Rider has managed access to to a certain specific type of resource, and that policy will apply to all the child compartments under Easy Rider. So you kind of inherit policies from the parent compartment. Very quickly here, in terms, so we've seen how subject, verb, and object and the object syntax works. Now we said that we can actually layer some granular controls on top of that. So here in compartment name, this group name has some verb access to this resource type, and then you add a work clause. And here now that extremely flexible syntax that allows you to basically specify certain specific object names. You can actually specify permissions. So I can say, for example, allow a certain group to manage all resources in a tenancy, and then where resource ID equals, or where permission equals. So even though the verb is very expansive and gives you full managed permissions, right, you're then overriding this in the granular control work clause. You're actually specifying, no, actually, I want only these specific permissions to apply to these certain specific resources, right? So, and with these key elements, the subject, the verb, the object, and the work clause, you can have full granular control over permissions to your resources in your tenancy. Something like this here. There it is. I mean, allow a dynamic group. So remember, we talked about dynamic groups. So these are all the computes in this compartment. Okay, so that is a dynamic group. It can manage all objects in this compartment. And then where? Okay, only objects in this bucket. Okay. So you can see now here how I'm doing the restriction. Without this work clause, it's all buckets, in the compartment. And then within the compartment, I'm restricting this to a specific bucket. And then not just only that, I'm also specifying the permissions. So only those two permissions, object create and object inspect. But I cannot do, for example, object delete. Okay. So this is very important from a security perspective and controlling access to your resources. Tagging. Very quickly, I want to touch on the concept of tagging. I think we have enough time. Freeform tags. This is a simple, you tag. So a tag is basically a key and value, right? A key and value pair, and you just basically stick that key and value pair to your respective resource, right? Now the thing is that can then lead to, it becomes now, if you're not really fully or well disciplined, then it can lead to multiple sort of rubrics for creating keys. Somebody wants to call an environment an environment, another person would refer to the key as env. If you want to instill some discipline in terms of how the naming conventions for your keys, another concept that we have is like namespacing. So you can have a namespace, and that namespace is pre-instrumented or seeded with certain pre-configured key values, or keys rather, right? And with certain conditions on the value. So you'll have like an environment key and a project key, okay? And that's your namespace. And then what happens now is when you, for example, spin up a resource, you can then attach, keys from this tag namespace. So you create a new compute instance, and you can then assign the environment tag to it. You're picking up that tag from a namespace rather than basically building that tag and configuring it in a free form fashion, right? So it's like a drop down list for tags, right? Now, so this is your namespace definition, and this is your key definition, environment, and that's the namespace. It's called operations. And then the tag here basically now becomes operations dot environment. That's your key, but the key is always prepended with the tag namespace, right? So we know that that's the key coming from this tag namespace, and then you can specify that value, call it production XYZ or whatever, or you can actually specify also, as part of the tag namespace validation, you can specify a predefined list of values so that whoever is attaching that tag to that respective resource is going to just basically have to choose, one of those values in the drop-down list. That's the idea, okay? Now, I'm going to basically move quickly here. You can also have tag defaults, so that, for example, you can say, okay, if this compartment has a tag default, any resource that is spun up in this compartment will automatically inherit, this tag, and that this tag key, and that tag key has a default value. An example of a default value is something like this. So I have a tag namespace here, and then created on and created by, and then I'm specifying. So in my definition, when I'm defining and setting up that tag namespace, I'm actually designating or specifying the default value for that key, right? So I'm not even allowing the user or letting the user kind of hazard the date time. It's automatic. The moment that key gets attached to the resource, the date time, at this moment is captured using this variable, right? And there's a set of variables that are available to us, including date time, principal.name. So you can say, for example, created by, XYZ, right? So this is an example of, the power of, defaulting, your tags. So along with defaulting and tag namespacing, this gives you a really good sort of mechanism to control, manage your tags and use them effectively across your tenancy. Final thing that I want to mention here before I move on to a demo, remember in our use case, on the left, we had, administrators in the default domain. These admins are basically monitoring your tenancy. We had the auditors, the admins are setting up your tenancy, et cetera, and then also, monitoring who has access to what. So we have a new service called OCI Access Governance. It's basically a first citizen service in OCI. It can connect with upstream identity stores. In our case, it can connect with identity domains. It will capture all the users, configure those users within Oracle Access Governance, and start monitoring the access permissions on these users or for these users, right? So it can connect via fulfillment or fulfillment connectors. It can connect into upstream IDPs, and then it starts capturing all the events happening in your IDP. So the moment, for example, a user is deprovisioned from Azure, for example, right? It will capture this as an event. Obviously, that user identity lives in Azure, but it also lives in OCI. So we need to monitor all the access permissions for this user in OCI, and not just only in OCI, but that can also across other enterprises, right? And across your other data centers and other clouds as well. So you can centralize access management within Oracle. So it's a fully fledged identity and access governance solution. You can capture identity lifecycle events. You can also then configure policies. So we have something called access bundles. You're basically saying, okay, these users fulfilling these certain conditions belong to certain roles or are assigned certain roles. These are enterprise roles, which are also then in turn assigned certain access bundles. These access bundles are nothing but a concept and abstraction that we use to encapsulate that notion of a permission, and permission basically on target systems, either within OCI or extraneous to OCI. Then you have this access request. Usually the ideal scenario, the typical scenario would be, okay, fine, a user is onboarded. Now the user logs into the access governance console and says, okay, I want access to this access bundle. access bundle, right? And that automatically then triggers a workflow where you a fulfillment workflow, which basically then involves multiple approvals. It could be automated, could be manual, depending on how you want to configure that approval workflow. And then once you're approved, that's it. You've been assigned that access bundle. And then, the access governance is going to then provision those policies in whatever target system, or if it's OCI, will then make sure that you're basically assigned to the relevant group so that you can then have access to the downstream target system. Right? Permission management, I've spoken about this already. And then access reviews. So that's post-fact, every now and then, every month or whatever, depending on the compliance framework that you're following, you will want to basically do an access review and just certify that your users and these roles have the correct access, not a permission more, not a permission less, right? So if I look at this is effectively what's happening. You start with identity collections, using those connectors to import your users into access governance, and then configure those access bundles, right? Specify, your application, what permissions you have in an app for an application that is an access bundle, and then you configure those roles, and the roles can have one access bundle or one or multiple access bundles, right? And then you can define those roles, and then it's via policies, it's which role is assigned to which identity collection. Once that is then specified, then it's basically reconciling with OCI and other targets. Now, very quickly, that brings to a culmination how this use case is going to work. All the elements we've covered, compartments, authorization, authentication, federation, right? Policies, right? We talked about a little bit about access governance. These are all the main sort of security, the native security services and the capabilities within OCI that we will leverage in order to fulfill that use case that we had presented, at the outset of this presentation. Let's very quickly have a look at a typical console here. The idea now here, I want to basically showcase to you authentication and how MFA works, and how we can actually segment users into groups, and how via policies we can actually restrict user access to certain compartments, right? So it's a simple use case, but it will showcase, give you a flavor of how these concepts and elements work in OCI. This is my profile. So I am now here, that's me, and I'm logged into this tenancy as an administrator. If you can see here now, this is the group that I belong to as an administrator. And if we can basically have a quick sort of view into an identity domain, okay? This is my default identity domain, and this is my default domain. And then look at groups. You could see here I have two groups, Unit A and Unit B. Let's have a look at Unit A. It has a user here. This user has access or is assigned to this group. Now, what does that group, what permissions or privileges does this group have? Let's have a look at policies. You go under identity, you click on policies, and you'll see here that there's a policy here with a couple of statements. The first statement stipulates that this group can manage access on all resources in compartment Unit A. Excellent. Now, I, as an admin, have full visibility into the system, right? So I can tell you that Unit A has one instance, okay, has a compute instance. Let's try and log in as this test user, okay? So this is now test one, and I'll have to quickly here capture the password, okay? So I'm going to connect here using the password, and okay, and that's demo 0, 1, 2, 3, 4. Okay, let's hope that works. Okay, I'm now, and it doesn't work. So let's go like this, test one, and just one last attempt. Demo 0, 0, 2, 3, 4. Okay. Okay, now I'm in. Notice, okay, so I don't have access to any applications. I'm gonna go like this. Let's see if I try and access the console. So I access the console. Okay, accept all. And you will see now here, when I click on instances, and I have this here pinned. When I click on instances, I'm in the console now, and I'm choosing the compartment. Notice now, if I go root, it says you don't have permission to view these resources. So I'm basically saying I want to see all the compute instances in this root compartment. If I go like this and select unit B, now we know that this user is not in unit B. So, and the policy explicitly says that unit A users can only see unit A resources, right? So let's try and go unit A like this, and there you go. Now I can see that there is an instance here. So we've seen now here the authentication, how the authentication works. I've logged into the console, how the policies work, and how compartments basically facilitate, alongside the policies, the separation of duties and, restriction of access to that particular compartment. One final thing, notice that I did actually log in without MFA. Okay, if you actually want to, you can actually click on security, and then you can enable two-step verification. You can choose, FIDO authentication. I have a YubiKey, so I'm going to select that. I'm going to continue. So now I'm enabling two-step verification for my user identity, right? And two-step verification enable, and then I'm FIDO authenticator here. Okay, and now I'm going to basically start setting this up. Okay, it's going to ask me for yep. And then, so a passkey, right? And then that's it. Now it wants me to touch my security key, which I've done. Passkey saved, and that's it. Now I have two-step verification basically enabled. Final step in this demo before we close. I'm now signed out, and then I'm now going to sign back in again. So obviously this is, we're specifying the second factor. So the second factor is going to be the FIDO authentication, but the first factor is my password, right? So I still have to use that password. Okay, and then demo 0, and then like this, and then if I sign in, excellent. And then you could see here now verify. Then all I need to do is touch, and that's it. We're in, right? Now, obviously in here, I don't have access to custom applications, but I do have access to the console. I click on the console, and then we're back in the console, and then I can basically see here, let's verify that I can only see my own compute instances. And then that's it, unit A, and that's it. So I think with this, we bring this to a close. I think this was a sort of a brief demo, but it kind of, encapsulated a couple of the concepts that we had been discussing. And that hopefully that was useful enough for you guys, gives you a flavor of the native security services and capabilities that we have in OCI. Obviously, we're just scratching the surface here, but feel free to reach out to us. We'll be glad to sort of connect with you, on an individual basis, and have, separate sort of more sort of in-depth detailed sessions to discuss about, the detailed aspects of security in OCI. Thank you very much for your attention.
Great session, Mohammed. I'm sure everyone learned something new today. Our next session will be on Monday, March 18th, where we'll cover core OCI networking services. You'll learn about how to deploy these services and best practice considerations for when and why to use these services. With that, thank you so much for joining us, and we'll see you all next time. Have a good day.
Thank you.